Good morning to you all. And I am now here to introduce the speaker of this afternoon, Professor Vijay Singh. Professor Vijay Singh is currently the president of Indian Association of Physics Teachers, and he was formerly professor of physics at IAPT Kanpur, and he did his PhD from University of Albany, United States of America in 1978. He was the coordinator for the national coordinator for national standard examinations conducted by the Indian Association of Physics Teachers. As you are all aware, Indian Association of Physics Teachers conduct national standard examination for junior science, physics, chemistry, biology, astronomy, and all these students who participate in this are eligible in the sense if they score the top 5 in the examination, they are eligible to participate in the international Olympiads. And Professor Vijay Singh was the chief national coordinator for these examinations, and also he was the team member for many of the teams which participated in international Olympiads. And I am very happy to mention here that since 1998, India is participating in this international physics Olympiad, and regularly they are getting gold medals. And 2 years back, 2018, all the 5 gold medals were won by the Indian participants. And after this, in fact, Professor Vijay Singh is very active on Facebook. In fact, he has got number of the YouTube experiments, very interesting experiments, and also physics for a common man. In fact, you will be surprised to know that Professor Vijay Singh has physics for journalists, physics for the poets. He has designed various interesting programs for journalists, journalists, and then poets, etc. In fact, very knowledgeable and highly respected physicist of the country. And I am happy to introduce Professor Vijay Singh, and he will be talking to you online. He is in Germany currently, and therefore he was expected here, but unfortunately he could not come. He is held up there, and therefore he said that I am going to speak to the youngsters from here itself. So we have organized this program, and I hope all of you will be benefited by his talk. Thank you. And I now welcome Dr. Shrikanta, who is the chairperson for this session.
Am I clearly audible, Chandan?
Yes, sir. Yes, sir.
Okay. Hello. So good morning to everybody. And I will need a little feedback from time to time if I'm clearly audible or not. That someone will have to tell me. If I am not audible or something happens, please let me know. I'm giving this talk from Berlin. So it is like 6:30 in the morning over here. 6, maybe 7 by now. But let me begin by saying that I wanted to be present in Bangalore for this talk. However, I am held up for some personal reasons in Germany. So let me begin by first thanking Professor Venkatesh for this very effusive introduction to me. And I would also like to thank Professor Nagaraju, Professor Achyuta, Professor Raghavendra, the Indian Academy for organizing this conference, and a very important conference. At the same time, I very fondly remember the IAPT members who, how should I put it, who have been organizing the NSSP, the National Student Science Symposium, for the last several years, Professor Manjit Kaur, Professor C.N. Kumar, and the Chandigarh group. So thank you very much, and thank you for having me over. Uh, Let me begin the talk. So I'll present, and someone will have to tell me if they can see the presentation. Okay. So my presentation is divided into some three parts. Okay. Let us see if I'm presenting. Wait. Can you see this? Is this? Hello, can you see this? Someone will have to tell me now because I can't see myself. Hello. Hello, Chandan, can you tell me if this is visible?
Yes, sir. Yes, sir. It is visible, sir.
You have to just give me a feedback, please. Okay.
Sir, I'm
So,
putting in chat box actually.
I can't read the chat box. I'm
Oh, okay.
actually giving the talk. So
Yes,
you
sir.
just
Yes, sir.
have to interject. Please go ahead and interject.
Yes, sir. It is
So this
clearly visible,
talk
sir.
is based. Okay. So this talk is about some personal reminiscence of the Olympiad and how it led to the undergraduate research program for me. Okay. And I will also like to mention that this is the centenary year of our founding president, Professor Khandelwal. So I honor him. This is also a year which is very important to my parent institution, my current parent institution, the Center for Excellence in Basic Sciences. It has called the Azadi Ka Amrit Mahotsav. We have 75 years of independence now. Okay, so as Professor Venkatesh mentioned, I was the national coordinator of the Science Olympiads. I was also the national coordinator of another initiative, the National Initiative in Undergraduate Science, which I will talk about very briefly. Okay, so let me begin. This is, I remind you, the Azadi Ka Amrit Mahotsav year, 75 years now of our independence. And I will go back because I have to talk about my personal reminiscence. So I'll go back about 40 years ago. Should I say 40? By now, yeah, it's 40 years ago when I came back to India after working in the United States and joined IIT Kanpur. The prevailing notions on Indian science at that time were the following. They said that the government institutions are ineffective and hopelessly quagmired in bureaucracy. Voluntary science bodies, like the IAPT or something, or NGOs, exist to criticize the government institutions and grab newspaper headlines. And then we have perhaps the world's largest manpower in science, but occupies some average position in world science. These were the notions that you heard if you sat at coffee table, across the coffee table with colleagues. You traveled in local trains, you traveled in trains across India. People would invariably get to this topic, and this would be the common notion. So, what I have to tell you is a small story, which is a true story, and the story is something which debunks all these myths. Okay, and my own journey began in 1990 when I was visiting the United States as a visiting professor for 1 year. Okay, and I went to see Bob Resnick, and I think you all know about Resnick and Halliday. They have a very famous book on fundamentals of physics. And what you see over here is something that Resnick wrote for me. He says, best wishes. He gifted me the third edition of his 2 volumes. Okay. But when I visited him, and you'll have to just indulge me for 5 minutes in this, because I have to tell you the early story. Uh, and when he gifted this, at that time he was very busy because he said he was training the American team for the Physics Olympiad, which would be held in Cuba that year. Okay. So this is 1991 now, because I'd spent a year there. And then he took me to a room where some of the best undergraduate, I would say high school teachers and undergraduate teachers of the United States were assembled. One of them was Professor A.P. French from MIT. And he asked me, why don't you also conduct an Olympiad and why don't you participate? Why doesn't India participate? And I said, well, I will try. And then he said, you do one thing. Here is a problem. You think your students can solve it? That was his question. Okay, so I said, I'll take it and I will try it out. Okay, so let me continue. After that, I made several attempts to start the Olympiad in India. IIT Kanpur was not interested. That was my parent institution. That is where I worked. The NCRT did not show much interest, unfortunately. And but there was one person who was behind me, and that was AP French from the United States. He kept writing to me saying, "What have you done?" And this is a sample letter from him in which he has written. This is from AP French. You can see it. Okay, this is MIT. This is some room number something. So he kept writing once in a while and saying, "What have you done, Professor Singh?" So finally, what I did was I got a chance to test his problem among our students. And I tested it in the most demanding exam at that time, and even now, the Advanced IIT Joint Entrance Examination. That was 1995. And the problem that he had given, I twisted it a little bit, but it was the same problem, was on the refraction of light by a medium which is continuously varying. I mean, it is not a medium which is, how should I say, a block with a constant refractive index. It is a block in which the refractive index is continuously changing, okay? And therefore, the ray of light as it comes in, perhaps you can see it, the print is bad, but I would still like you to see it, and the ray just bends upwards. This is what is sometimes called as the mirage problem. Okay, that's how you see mirages, because the refractive index of air changes continuously as the air gets hotter when it reaches the ground. This is 1995, problem number 3. And to my great surprise, I found that among the 18,000 students who had taken this exam in the Kanpur zone, okay, and this was a high pressure exam where students tend to ignore the more difficult problems, about 8 to 10 students had gotten this right. So this gave me some confidence. You know, I was sure about the abilities of our students. This gave me some confidence that we can start. If we did the Olympiad program, we would do well. Let me continue. Okay, this is 1998 now. Uh, there was an agreement between IAPT and the Department of Atomic Energy and the Homi Bhabha Center for Science Education to start the Olympiad program. At that time, I was the editor of the IAPT bulletin, and I jumped on it and I said, the Physics Olympiad is going to start. This is the asset test for any student at the 12th standard level because it has 5 hours of theory and it has 5 hours of experiment. It has both, in fact. Okay. So we welcomed it and I got involved in it right from the day zero, I would say. Okay. I was in IIT Kanpur, but we started the program in Mumbai at the Homi Bhabha Center. And I used to make periodic visits. In fact, I used to spend about 2 or 3 months in Bombay at that time, every year, until I moved permanently to Bombay in 2004. Okay. So let me continue. And I'll just remind you, I mean, some of you students are new, but I will tell you, this is just the first half. In the second half, I will talk about an undergraduate research, which I carried out in the last year with a high school student, in fact. Okay. But the Olympiad program is a 5-stage program. The first stage was actually handled almost entirely by the IAPT, the Indian Association of Physics Teachers. So what you do is you take about 40,000 students, whittle them down to 300. Then you have from 300, 1/10 of it, say 40,000 to 400, 400 to say 40, who are given special training. And then from that, you select 5 students in physics, 4 in chemistry, and 4 in biology. And they all then go to an international location where another 5 students from another country, from all the countries in the world, assemble. Right now, there are about at least 90 to 100 countries participating. So you can multiply 90 into 5, that is 450 students participate. And this happens internationally every year, except this Corona years, this COVID pandemic years, when they have not quite happened. Okay. Now you'll be very surprised. Unlike any entrance exam, this exam used to cost only 50 rupees per subject for the students. And that was because It was handled by the Indian Association of Physics Teachers, okay, chemistry teachers and biology teachers, primarily by the Physics Teachers Association, and primarily because the work is voluntary. Okay. So let me continue and say what happened in 1998 when we participated in 98. But before that, I'll just backtrack and remind you that there are 5 hours of practical and 5 hours of theory with only 3 questions. The theory exam is only 3 questions. 60% weightage is given to theory and 40% say to practical, and about 10% of the students get gold medals. Okay. The paper is set by the host nation, and because many countries are not conversant with English, this paper is translated into various languages by the respective members who accompany the 5 students. There are 5 students who go, and about 2 or 3, or how should I say, leaders or mentors who go along with them. One day before the exam, they know the exam, they are told about this exam and they translate it. Okay. So there are 5 students, but there are say, at least 2 or 3 mentors or leaders or professors who go with them. And usually in physics, these professors have been from the Indian Association of Physics Teachers. Okay. So this is our first, okay. Now, this is our first foray into the Olympiad program. This is 1998 in Iceland, where 58 nations participated. Okay. We got 1 silver, 1 bronze, and 3 below the bronze. They were called honorable mention. Okay. And that gave us some confidence that yes, we can at least get a medal. In 98, we got at least 1 silver medal and 1 bronze medal. Okay. The 2 leaders who accompanied them were our previous president of the IAPT, Professor H.C. Pradhan, and Professor T.S. Natarajan, also an IAPT member from IIT Madras. It's not IIT Chennai, it's a mistake, it's IIT Madras. Okay. So here are the 5 students, but here is our president or ex-president, Professor Pradhan, and here is Professor Natarajan. Okay. And these were the 5 young students who are all doing very well right now. In fact, Mr. Saikat Gua has got a double professorship, one in Boston and one in Arizona at the moment, and works on quantum computing. Okay. So after 98, we went to Italy in 99, to England in 2000, etc., and we have been going on and on after that. Okay. So we have gone every year, except I think in the last year, because of the pandemic. In 73, 78, and 90, it was not held. And what happened was there is another Asian Physics Olympiad which the IAPT does solely, and that was hosted by us in 2012 in Delhi. We hosted the International Physics Olympiad. The IPHO stands for the International Physics Olympiad in 2015, and the next year the IAPT is going to host the Asian Physics Olympiad 2022 in Dehradun. IAPT is the mainstay of the Asian Physics Olympiad, and I would say even of the International Physics Olympiad. Okay. So here is our first participation, 1 silver, 1 bronze. Let us see what happened in the second participation. In the second participation, we made a quantum leap. We got 4 golds and 1 bronze. Okay. And there's 2 people I would like to single out. I mean, I can tell a story about every one of these characters in the photograph, all the 5 students. But there's one person who stands out, and that is Professor Dharkar. He was the national exam coordinator for the first level exam, in which about 40,000 students would appear in physics. And now, I mean, at least forget about last year, but prior to that, at least about 2 lakh students would appear in this exam. The other person I would like to single out, this is myself, but the person I would like to single out is Subrat Raju. He is in Bangalore. Professor Subrat Raju is in ICT, the Institute for, I think the ICTS, the TIFR Center for Theoretical Sciences, which exists. He's a member over there, and he's doing very good string physics and physics over there. Okay. There's one more picture of Professor Dharkar that I would like to project. He passed away last year. This is again Professor Dharkar in Italy. And to just give you a flavor, this is Italy, of course. You can see it's very sunny. It's the summer of 1999. This is Professor Abdullah Sadiq from Pakistan. So although there are countries which are participating, which are normally politically at loggerheads with each other, there is no politics in this International Physics Olympiad. So we were very good friends. Okay. So now we have 4 silver and 1 bronze. And then in 2000, we went to England. And lo and behold, we got 2 golds, okay, 2 silvers and a bronze. Okay. And this was a wonderful event because in 62, there were 62 nations participating in 2000. Okay. I had taken the team along with 2 other people whom I will mention now. But just to backtrack, this is in the entire world of 62 nations in those days, we stood number 3 in the world. Our rank was number 3. And there's one other person who was the mainstay of this program, Professor Arvind Kumar. He was the director of the Homi Bhabha Center for Science Education. And he, along with Professor Dharkar, are the 2 people I would like to single out. Along with now, there are other people who are no less important. Professor D.A. Desai, who was a great mentor for the experimental part of our program. I don't want to go over it, go through the litany of it, because I want to go ahead and mention some research work that we did with undergraduate students. But what I would like to say that we had jumped from just 1 silver and 1 bronze to 2 gold and number 3 position. We improved this position in 2008 in Vietnam when we got 4 golds and a silver. Okay. And the team that went was accompanied by these people, Pramendra Singh and Charudat Kadolkar, who did a wonderful job of guiding these 5 students. Okay. By the way, some of the students that you see are the who's who of India. This is Shitikant, who stood number 1 in IIT, whose rank was 1. This is Nishant Totla, rank number 2, and Garvit Juniwal, rank number 10. So we had some of the best students in these Olympiads, and we groomed them. Okay. So this is 2008. I would like to introduce to you a couple of other key players of this Olympiad program before I leave this topic. Okay. This is the 2005 team, which went to, I believe they went to, where did they go? I think it's either Singapore or something, but this is the 2005 team. What you see here is Piyush Srivastav. He's a professor at Tata Institute of Fundamental Research in Computer Science, IIT rank 1. Okay. But there are 4 other people 3 others I would like to introduce. This is Professor Bhupati Chakrabarti. He was our ex-general secretary. This is Ravi Bhattacharya, who handles the Asian Physics Olympiad. He is the APHO coordinator. And this is Rajesh Khapade, who set up the experimental lab at Homi Bhabha Center, where all these 5 students were trained. By the way, it goes without saying that Piyush Srivastav and one other student, Samir Madan, got the gold medal. And then you can see students from Bangalore also. Arjun from Bangalore. Okay, this is one of my favorite pictures because it has once again Raghu Mahajan, who is IIT rank 1 in that year 2006, and right now at Stanford University doing physics. These are all guys doing physics. But there's another iconic figure that I want to introduce, and that is B.N. Chandrika, the late B.N. Chandrika, who was also our general secretary way back. She passed away along with Professor Dharkar is also no more. So these people I would like to honor. And Chandrika madam is from Bangalore. Okay. Oh, so I should also talk about, this is Raghavendraji 2011 team. He took the team over to I think, where did you take Raghavendra? Can you tell me? I mean, I forget where the team went. So this is Raghavendra with the Indian team. He was one of our leaders. And Raghavendra is in Bangalore. Before I leave this topic and show you, once again, I want to show you Chandrika madam. I would like to mention one thing, and that is after Professor Dharkar left, the national coordinatorship for the exams was taken up by Professor Oglapurkar of Pune, and then the person who introduced me so magnanimously today, Professor Venkatesh, and then right now it is Professor Tyagi. Okay. So I honor these students, I honor these people, and let me now just mention a few things. This is our performance. In 2001, in Turkey, we got 3 golds and 2 silver, and we continued getting golds, but not 5 golds until it was 2018. Now, I think you should just focus on this. As Professor Venkatesh mentioned, we got 5 golds in 2018. Okay. And at that time, I believe Professor Venkatesh was the national coordinator, and he was the first level exam coordinator. Our second best performance has been 4 golds in Vietnam. I showed you the picture. Hello, who is this? Hello.
Hello, good afternoon, sir. This is Virti calling from Amchagar.
I'm sorry. I'm giving a talk right now. Hello. I'm really sorry. There's some interruption. I have to keep my phone on because something happens to this talk, then Achyuta can call me. And we got 4 golds in 2008, 2009, and 2017. So our performance has been very good, I would say. And in fact, it has been something which should make India very proud. Okay. Okay. And this is a map of India. It says that this program took off because of the IAPT in collaboration with ACT, the Association of Chemistry Teachers, and the Association of Teachers in Biological Sciences, and the Homi Bhabha Center in Mumbai. Okay. So what is the moral of the short story? The moral is that the government institutions are effective. For example, the HBCSC. The voluntary science bodies collaborate effectively. They don't just exist to criticize the government. And the IAPT is a shining example of it. And we have perhaps the world's largest manpower in science and occupy a very high rank in physics, chemistry, and biology at the high school and the undergraduate level. So the issue is when you criticize, I mean, you should also see the positive things that have happened in India over the last 75 years. Okay. So then the question is, what is the auxiliary work that we do in IAPT? See, after Olympiad, what? We found that we found that our weakest point is the undergraduate program, because at the undergraduate level, students get apathetic. They are not given challenges enough for carrying out their work. So I'm very happy that Professor Nagaraju, Professor Achyuta, and the Bangalore group has got together to organize this seminar to highlight undergraduate research. Okay. So I would like to tell you that I also did that to some extent, because I realized that the Olympiad program was not sufficient. Okay, if you have good students and you do not give them good challenges, then they would wither away. So we started a program called the National Initiative in Undergraduate Science. And part of that program, you can see the NIUS, there are many parts to this program, but a very important part of the program was UG student projects and research. Okay. So I would like to highlight just one research over the last year. So this is a sample research, and I'm saying this not because this is the only research that was carried out. I'm sure that in the next 2 days, we will hear very good research activities by undergraduate students. But this is what I did over the last year during the pandemic. Okay. So, and this is an example from 2020-21, recent example. So this last 10 minutes of my talk, I would like to beg your indulgence, and I want you to pay attention to this talk. Okay. Okay. Seeing the Himalayas from the plains. This is the title of the talk. This work was carried out in the last 2 years with the help of a student, Arnav, okay, who was in 11th standard student when 11th standard when he started the work, and 12th when he completed the work. Okay, so the Himalayas, as we know, have exercised an eternal fascination for India. This is Kalidas, okay, Kalidas in the Kumar Sambhavam. And what does he say? On the northern frontier of this country that forms the heartland of gods, intercalating himself into the eastern and western oceans like a measuring stick of earth, there stands the sovereign of snowy mountains renowned as the Himalayas. So since Kalidas's time and even before that, the Himalayas have exercised a great fascination for India, for Indians and for the world, I would say. I mean, it's not just Indians, you will see it's for the world. The mountain that you see in the background is basically the three peaks of Gangotri. Gangotri 1, Gangotri 2, Gangotri 3, as it is lit up by the morning sun. So it has a golden color. Okay. So in the 18th century, I go back and say that the Himalayas were interesting not just to Indians and Hindus, but they were interesting even to the British. Sir William Jones, who founded the Asiatic Society of Bengal 1784, was visiting North India. He was visiting basically Bhagalpur in Bihar. His successor is Henry Colebrook. And what happened is the following. Both of them, from Bhagalpur, William Jones claimed, at a distance of more than 300, 400 kilometers, I think, claimed that he saw a peak. Okay. And then 10 years later, when Henry Colebrook visited another place in Bihar, which is north of Bhagalpur, that is Purnia, he too claimed that he had seen a peak, the same peak. What was that peak? That peak was called Mount Jomalhari. That is what was claimed by our friend, by our colleague, by our ex-colleague, by the great founder, Sir William Jones. He was the greatest Orientalist of all times, they say. Okay, he was a Sanskrit scholar, he was a high court judge, he was everything. Okay, and his successor was no less renowned, I mean, Henry Colebrook. So they claimed that they had seen this peak, which is 7,326 meters high. Okay, I'm showing you that peak, that very peak. This mountain is considered sacred by the Buddhist and the locals of the region. Okay. So what I did was I had Arnav work out if this was really possible. Is it possible that from this place in the plains of India, and I will show you that place in a minute, Bhagalpur, on the bank of the Ganga, can you see this peak? Okay. And I'm showing you the location now. This is a map of India. This is Bhagalpur. You can see the blue line, which is the Ganga. Okay, and a little north east of it is Purnia, from where Henry Colebrook saw the same peak. Which peak did they see? This peak number 8 over here. If you can see my cursor. Is my cursor visible, Chandan? Oh, he's not here. I need a little feedback from time to time, but okay. Is it visible, Arnav?
Yes, sir.
Okay. So this is the peak Jomalhari. Okay. And they claimed that they had seen this peak. In fact, what Henry Colebrook had done, he had even measured the angular width of that peak. Like 1 minute it was or something. What is number 3? Number 3 you can see is Darjeeling. What is number 5 is Kanchenjunga. And you can see from here, this is Jomalhari and this is Kanchenjunga, and 4, 6, and 7 are the great peaks of the Himalayas: Mount Everest, Mount Makalu, and Mount Lhotse. Okay, so you can see all these peaks here. Okay, and this distance is quite a bit. Okay, so I will backtrack again now. Okay, this is Henry Colebrook in around the late 1780s. Around 100 years later, okay, this is Maxwell. Maxwell wrote to Lord Raleigh in 1873, and I think you have all heard of James Maxwell, okay, and also of Lord Raleigh. James Maxwell is actually the one who unified electricity and magnetism. He wrote to Lord Raleigh wondering if one could see Everest from Darjeeling. and he requested him to work out a calculation by writing a following letter to him. Lord Raleigh did not respond to this letter. Maxwell died 6 years later in 1879. In 1897, Lord Raleigh visited visited Darjeeling, and he saw Mount Everest, which was 160 kilometers away. Okay. And he wrote a very, very famous paper in 1899, which even Raman has quoted, which everybody quotes, on the blueness of the sky. And that paper was inspired by his visit to Darjeeling, where he saw Mount Everest, and was inspired by the letter that James Maxwell wrote to him. Okay. He says, I'll quote Lord Raleigh, although Mount Everest appears fairly bright, 100 miles, 160 kilometers distance, as seen from the neighborhood of Darjeeling, we cannot suppose that the atmosphere is as transparent as is implied in the above numbers. Now look what Lord Raleigh is saying. Lord Raleigh is saying that the earth is round and you can geometrically see Mount Everest, but can you actually see it because the air absorbs light? Is it visible? So there are two questions. One is a geometrical question of whether you can see a certain place, why the horizon is about, like for a person who is about 2 meters tall, the horizon is only about, how should I put, about 7 or 8 kilometers away. That is the geometrical question. The other is the pollution question or the air molecule question. Does the air not absorb light? Can you actually see it? Okay. So the first problem is the geometrical problem. And of course, long ago, Arvind mentioned this. He said, Bhugol sarvatva vritta. He said the earth is round. Therefore, the maximum that you can see is this formula that I have highlighted. Forget the derivation of this formula. You are here at a height of h, and you can only see up to the tangent point to the earth. And what you see, this round circle, is a section of the earth. So it's a circular section. So this distance d is 3.57 into h in meters, but the distance comes out in kilometers. I worked out all the units for you. See, if h is 4 meters, if you say 4 meters at a height of 4 meters, say the first floor of a building or something, of a structure, so square root of h is 2, okay, and 3.57 into 2 would be 7, say about 7 kilometers. That's all that you could see. But for example, if you are 7,000 meters high, if you're 9,000 meters high for some reason, then the square root of that is pretty large. Okay, so 8,000. How much is Everest? Everest would be about 8,100 meters. Square root of that would be 90. 90 into 3 is how much? 90 into 3 is 270. I want you to work it out right now. 90 into 3 is 270, and another 0.5 to it. So that's another 45. So that's about 320 kilometers is all that you can see. Even so, from a place 320 kilometers, 300 kilometers away, you could possibly see Mount Everest. But there is another question, that is the visibility question. Okay. So first, I want you to appreciate how the calculations went for Arnab. Okay. Of course, I was just asking him to do it. He did all the work. How it went. First of all, he did the geometrical calculation, and next he did what is called the visibility calculation. The intensity of light, you can see this graph, the intensity of light drops as you go a distance x. Okay, so if you go a distance far enough, the exponential will just kill it down, like it's the radioactive decay function or the exponentially dying function. So one can actually see a mountain, okay, but the intensity of light decreases as it goes through the so-called transparent atmosphere. That's called the visibility problem. So there is a geometrical problem he worked out, there is a visibility problem he worked out, and the third problem that he worked out, which I will tell you in a minute, is different. But right now what we decided after he did the calculation, I checked the calculation, is that Mount Jomalhari is certainly not visible from Bhagalpur. It says not visible. From Darjeeling, yes. And from Darjeeling, even Everest is visible. Okay, but Mount Jomalhari is not visible from Bhagalpur. So perhaps what Sir William Jones saw, the great Orientalist and founder of the Asiatic Society, saw was now not Mount Jomalhari. We figured out after some calculations that it was Mount Kanchenjunga. And we have put our neck out and we have said this. So the great Orientalists perhaps erred. Okay. There was one more effect that bothered us, and that's called refraction calculation. What happens is that the air above is rare, and you remember the first problem at the JE 1995 problem. The air is rare and then it becomes dense. So instead of seeing just the geometrical distance, you see my cursor, you will actually, light will bend and you will see much further. So one can see further due to refraction. And AP French had actually worked out this calculation earlier to show that what you will see is not just D, but 9% more than D because of refraction. You see the ray of light as it bends this way. The calculation is involved. It's not simple, but it can be done, even by a 12th standard student and certainly by an undergraduate student. This picture that I'm showing you is that of a ship, okay? And this is from England, very recent BBC, the BBC put out this picture and this video that they could see a ship in air, okay? And that is because of refraction effects, okay? The ship is not on the sea, but you can see it in the air because of refraction effects. Okay, so we felt that even with that 9% correction, you could not see Mount Jomalhari from Bhagalpur. So we have ruled out all three effects. One is the geometrical, the other is the visibility, and the third is the refraction. Okay, and what we did was then we sent this for publication to the American Journal of Physics. The editor was very happy to get this manuscript, which was a historical manuscript mentioning Weisskopf, mentioning Maxwell, Rayleigh, William Jones, and Henry Colebrook. So this is a 2021 paper. You can read it up. If you cannot find it, please write to me at my email address, and I'll be happy to share it. I would like to highlight the student who actually did the work. Okay, and I was just a small mentor for him. So what is the lessons to be learned, students? You will be presenting in this conference new work. Okay. And basically what you will say, essentially, if it is a new piece of work, you will say, do not accept anything on faith. Okay. Also, even the best people can make mistakes. William Jones made a mistake, Henry Colebrook made a mistake, and a person who reviewed their work, Victor Weisskopf, who was the head of the Department of Physics in MIT, also made a mistake. The third is good research, why at the undergraduate level, even at a school level, is possible. And the fourth lesson is that his entire work with the student, Arnav Singh, was done during COVID times. It was a real struggle because we never met. We just did it over email and so on. Okay. So COVID-19 confinement was tough, so it was a struggle. So you have to do all of this, young students, and I will encourage you to present your work and put your neck out and challenge even people who are way up there. I will show you a few other students with whom I worked. Okay, just a few. I mean, there are at least 20 of them who have published with me. This is Akashdeep Kamra. He published in Physical Review, undergraduate, as an undergraduate student in 2008. Right now, he's a faculty at Madrid. This is a very famous student, Muralidharan. He published about 6 papers, or 8 papers in international journals as an undergraduate student. Okay, and he was at Delft. I forget where he is right now. This is Raghu Mahajan. I've shown his picture to you. He also published with me actually, in Pramana, and he's at Stanford. Here is a young girl. She comes from Bihar again, from Nalanda. Okay, and she is currently at Helsinki. She did a PhD from there. She published in the European Journal of Physics in 2011 on nanostructures with me. And there's another girl who is currently in Würzburg, Germany. She is doing her PhD, and she also published in the European Journal of Physics in 2016. So the point is, undergraduate research is possible. Undergraduate research is desirable. Okay. Undergraduate research is something that if you publish a paper with the student, I think I would always say a publication is like first love. You never forget your first love. Okay. So when you fall in love with somebody, you can never forget her. Or if you're a man and if you're a girl or a boy, the man. So it's like that. So they will something that as a teacher, if you mentor them, you will be remembered for a long time. Okay, and you will also they will also go to great places because of this publication. Okay, so dear students of the symposium, I would encourage you to work hard, okay, and do research also. You do your academic work, but you also do research. Thank you. I'm done. I'll stop sharing. I don't know, how do I stop sharing now? Is there a way to stop sharing? Yes, I've stopped. Okay, so I'm done. Have I taken enough overtime?
No, sir, it was perfect. Thank you.
Okay. So thank you very much. Once again, I recall Nagaraju, Professor Nagaraju and Professor Achyuta. I thank them for organizing this. I thank the Indian Academy. I also thank Professor Venkatesh and his colleagues for organizing this and inviting me to this talk. And I fondly recall the Chandigarh group, which started this whole thing about 10 years ago, 10, 15 years ago. Manjit Kaurji, C.N. Kumarji, and others.
And you have spoken very nicely to the students, and of course, you have encouraged research at the undergraduate level. We should thank you. Because of time, I am not taking much time to tell you all those things, what you have said about refraction and then student projects. But anyway, you have encouraged a lot to our students. Thank you very much. We will meet again in some other place. Thank you, sir.
Thank you.